Equations with rational exponents. Our first example is x to the 3/4 equals 8. So first, we would isolate the expression with the rational exponent. Our expression is already isolated, so we're just going to rewrite it here. If we needed to isolate it, we would. Next, raise both sides of the equation to the reciprocal power. The reciprocal of 3/4 is 4/3, so I'll raise the left side to 4/3 and the right side to 4/3. Third step, solve. Since the reciprocal power, 4/3, has an even numerator, we may have an extraneous solution. But instead of just remembering that, I think it's just always good to check our solutions. So, power to a power, we're going to multiply our exponents. 3/4 times 4/3 gives us the 1. So x to the 1 are just x equals 8 to the 4/3 power. Simplifying, that means the cube root of 8 to the 4th power. The cube root of 8 is 2. 2 to the 4th power. X is 16. Okay, so let's check our solution. And when we check our solution, we always need to check it in the very original equation. So we will substitute 16 into x to the 3/4 power equals 8. So 16 to the 3/4 power, does that equal 8? So the 4th root of 16 raised to the 3rd power, does that equal 8? The 4th root of 16 is 2. 2 to the 3rd power, does that equal 8? Yes, 8 equals 8. So our solution checks out, and our equation solves to x equals 16. Our second example is x plus 5 quantity raised to the 2/3 power equals 64. So again, first, isolate the expression with the rational exponent. And again, ours is already isolated, so we didn't need to move anything to the other side. So I still have the same equation. Then we will raise each side of the equation to the reciprocal power. The reciprocal of 2/3 is 3/2. So I'll raise the left side to the 3/2 power and the right side to the 3/2 power. And then we'll solve. And then since the denominator of the reciprocal power is even, we will need to include plus or minus when solving. It's the same thing as when we're taking the square root of both sides of an equation. We need to have a plus or minus. Same thing here. So power to a power, we need to multiply our powers. 2/3 times 3/2 is 1. So we have x to the x plus 5 quantity raised to the 1 power, or just x plus 5, equals 64 to the 3/2 power. X plus 5 equals plus or minus the square root of 64 cubed. X plus 5 equals plus or minus the square root of 64 is 8, so 8 cubed. X plus 5 equals either 8 cubed or x plus 5 equals negative 8 cubed. So x plus 5 equals 512, or x plus 5 equals negative 512. So for the first one, to get x by itself, we'll subtract 5 from both sides. X equals 507. In the second equation, I'll subtract 5 from both sides. X equals negative 517. And again, check both solutions in the original equation. So 507 plus 5 to the 2/3 power, does that equal 64? 512 to the 2/3 power, does that equal 64? The cube root of 512 squared, does that equal 64? The cube root of 512 is 8. Does 8 squared equal 64? Yes, 64 equals 64. The first solution, 507, checks out. Let's check the second one. Negative 517 plus 5 raised to the 2/3 power, does that equal 64? Negative 512 raised to the 2/3 power, does that equal 64? The cube root of negative 512 quantity squared, does that equal 64? The cube root of negative 512 is negative 8. Negative 8 squared, does that equal 64? Yes, 64 does equal 64, so that one checks out as well. So we have two solutions. Our solution is 507 or negative 517. Let's look at one more example. We've got the quantity 2x minus 3 raised to the 9/7 power equals negative 1. So again, isolate the expression with the rational exponent. And again, this example also already has our expression isolated, so we don't need to isolate it here. Then we will raise both sides of the equation to the reciprocal power. The reciprocal of 9/7 is 7/9. So I'll raise the left side to the 7/9 power and the right side to the 7/9 power. And then we'll solve. And because both the numerator and the denominator of the reciprocal power are odd, we will find just one solution. So here, power to a power, we're going to multiply the powers. 9/7 times 7/9 multiply to get 1. So I have 2x minus 3 in parentheses raised to the first power, or just 2x minus 3, equals negative 1 to the 7/9 power. 2x minus 3 equals the 9th root of negative 1 raised to the 7th power. 2x minus 3 equals, okay, the 9th root of negative 1 is negative 1. And then we've got negative 1 to the 7th power. 2x minus 3 equals negative 1, because negative 1 raised to the 7th power is still negative 1. Getting x by itself, I'm going to add 3 to both sides. So I have 2x equals 2, and then divide both sides by 2. X equals 1. We should still check our solution in the original equation. So, does the quantity 2 times 1 minus 3 raised to the 9/7 power, does that equal negative 1? So the quantity 2 minus 3 to the 9/7 power, does that equal negative 1? Does negative 1 raised to the 9/7 power equal negative 1? Does the 7th root of negative 1 raised to the 9th power equal negative 1? The 7th root of negative 1 is negative 1. Does negative 1 raised to the 9th power equal negative 1? Negative 1 raised to the 9th power is negative 1. So yes, negative 1 does equal negative 1. That checks out, and our solution is negative 1.